So today we discuss important electrostatic physics. Okay, so that is a Gauss's law and electric flux. Very important topic is Gauss's law and electric flux. Okay, so Gauss is a scientist. Okay, a German mathematician, Carl Friedrich Gauss. Lifespan is 1777 to 1855. Lifespan of Gauss's, and a German mathematician. And before we discuss Gauss's law, the another important is electric flux. First, we clear what is a flux and what is the behind the concept of flux. Okay, so let's consider a plus, suppose a plus 1 coulomb charge. Here is a plus, suppose 10 coulomb charge, and that is a minus 5 coulomb charge. Okay, and we know that electric field, if plus 1 coulomb charge, electric field always outward direction. That's the electric field. And plus 10 coulomb charge, base electric field in outward direction, but is a more dense than 1 coulomb charge. And that is minus 5 coulomb charge, means electric field inward direction. Okay, so we consider a imaginary surface here. Consider a imaginary surface means a 3D sphere, a 3D object, that is an imaginary surface or imaginary sphere, that is 3D, very sphere is 3D. Okay, or a imaginary surface. Okay, we see that the important things, there is a surface, okay, and that is the electric field. You see that if you don't know what is inside the surface, we see there is some electric field or piercing the surface in outward direction. The surface in outward direction. And if I similarly see that a draw imaginary surface 3D draw, I see that similar concept, electric field piercing the surface, pierce the surface and goes outward direction. But the difference is here. We see that here electric will obviously piercing the surface, but that is a inward direction. That is, both are in outward direction electric field, that is the inward direction. Okay, see, electric field is a vector field, we know that, and electric field pierces the surface either inward direction or outward direction. But the main important is the pierce the surface inward and outward, and these imaginary surface enclose some charges, either positive charges or negative charges, they don't know. Okay, but if you see carefully in electric field direction, you tell that if a charge enclosed is either positive or negative, if you concept the electric field in direction with charges. And you know that in previous class, if you carefully do that previous class or see the previous lectures, you know that electric field always from plus to minus direction. Plus to minus direction. So here you see that electric field outwards means this surface, suppose that is a black box surface, we don't know what is the inside that box. We don't know inside the surface here. Actually, if I see the electric field tells that that is a means here is a plus charge enclosed by the surface. Okay, plus charge enclosed. And here see that electric field is obviously minus. We similarly say that this surface enclosed positive charge. And similarly, this surface, electric field is inward direction. We say that this surface enclosed minus charges. Okay, so if you write that the electric field is a vector field, electric, note that field is vector field. E appears an imaginary spherical surface here and imaginary spherical surface. The spherical means 3D. Okay, this spherical means 3D. Okay, 2D is circle and 3D is sphere. And this surface is known as a Gaussian surface. This imaginary surface is another name is called Gaussian surface. Okay, the Gaussian surface and is defined by the user actually. So surface, another name is called Gaussian surface. Gaussian surface that enclosed by charge. Let's say that enclosed, okay, by charge plus q or minus q. Okay, so actually Gauss's law tells, suppose there is a gift box as a wrapping outside the gift box. The Gauss's tells that what inside the gift box by looking the wrapping paper. Okay, so Gauss's are very beautiful things. They tells that what inside the gift box by looking at wrapping paper. So like the what inside the book and what is the content in the book, we see the cover of the book actually. They decide the cover of the book. The Gauss's law tells that. So Gauss's law tells that that what inside the gift box, either plus or minus sign, by looking the wrapping paper. Okay, so another important thing is called flux. Okay, tells that a flux. There's a very easy. Okay, the flux is that how much electric field pierces the surface. Quantitative numeric number is called electric flux. Okay, so the flux phi, the symbol phi, that is a suppose that is E. Suppose consider a diagram here. Uh, this diagram consider. Okay. Suppose consider a surface like this. This is a surface. And suppose this consider a surface. Okay. This is a surface, and that is called area. Okay. So consider small surface of sphere is that is delta A. So suppose that we tell that E dot delta A piercing the surface. Okay, an amount of electric field causing that the piercing the surface is delta A. So flux phi tells that the how much electric field piercing the surface. Okay, that is a quantitative, that quantitative, the quantitative. Okay, a measure is called electric flux. Quantitative measure is called electric Quantity means a number. Okay, that is a number. That's why flux is a scalar. Flux is a scalar. So get a E is a vector and area also the vector. If I dot product these two vector, we get a scalar. Okay, so dot product is a scalar product. Suppose you consider suppose very easy concept. Consider a surface. Okay, square surface here. That's a charge I think. First new page. Draw a surface like this and consider a charge like a positive charge here and that's the small area delta A, that is a small area and area is a vector. Okay, that's area is a vector and that is area vector always delta A always normal to that surface. Okay, or perpendicular to the surface. So I see that E here, so electric field in that direction. Okay, piercing that surface. Okay, and now calculate the electric field in y direction and electric field in x direction. If the angle is theta. Very easy, we know that. So if I consider know that the flux phi that is equal to EA. So if I solve this, that is means E delta A cos of theta, and that theta is the angle between E and area vector, electric field and area vector, that is a theta. So that means a Ex. Okay, that is a Ex. So here you see that suppose the phi x. So electric field in x component of the electric field. Okay, that is x component of electric field. That is a basically E cos theta. E cos theta. So here we see that E cos theta that is also equal to uh, theta. We get if E cos theta, so means E times delta A, that is equal to E cos theta delta A cos theta. So Ex actually that is a X component. Okay, that is a X component and theta is the angle. So angle if Ex in that direction, if Ex in that direction and area vector in same direction, if both are in parallel, that is theta equal to 0 degree and you get cos 0 1, that is Ex times delta X, that is phi x. And if I E number of flux crossing that are piercing the surface in y direction. Okay, what is important thing that electric field in y direction. Okay, that is a y direction. So that is electric field goes in that direction actually. So Ey in that direction, but delta A in that direction. That is a theta actually. Now, but here Ea actually now look like this. There is a surface. That is the area. That is the delta A vector, and that is the Ex. Both are in same direction. That's why theta equal to 0 degree, theta equal to 0 degree, and Ey means if Ey similar condition is upside in electric field direction, actually skimming the surface, touching the surface, okay, not piercing the surface. That electric field in y direction means that is skimming the surface or the surface. And here electric field Ex is a piercing the surface. the surface. That's two important point. Skimming the surface, electric field, but area in that direction actually. So in case of y, that is a EY, and that is a delta A. The angle between these two, that angle between these two is now 90 degree. So phi of y, that is equal to, suppose say that EY, okay, but delta A and cos 90 becomes 0, okay. So that is a phi y equal to 0 and phi x equal to some value here. So that is the physical significance is that the electric field always here, the piercing the surface. That's important thing. Electric field always piercing the surface. Skimming the surface, the flux is 0. Okay. Say if you see that tree diagram here, all cases that all electric field pierce the surface, either inward direction or outward direction, but they're piercing the surface. They're not skimming the surface. Skimming the surface will look like this now. In the case skimming the surface, now electric field in that direction. That is skimming the surface. That is impossible. It is impossible. So no, actually the area, this area, if electric field skimming the surface, so means no charge enclosed. Actually, this surface is zero charge enclosed, either positive or negative, as a neutral. Okay. If we are skimming the surface electric field means this surface is no bounded charge here. You are skimming the surface. Okay. So amount of electric field is always piercing the patch and defined to the electric flux. So electric flux is important. Flux is say that amount of electric field piercing the patch. Piercing the patch. The patch means the area. Patch means the area. Consider a small area. Okay. Patch is defined to the electric flux. Is defined to the electric flux. But in EY case, the electric field is not a piercing the surface, skimming the surface means this surface is zero charge enclosed actually. If that skimming means the charge is here actually, the positive charge is here, that's why it's skimming. Okay, suppose draw a diagram like this. If a positive charge here, electric field in that direction, in that direction, in that direction. If we consider a surface here, that here surface, we see that this 3D surface, I mean sphere, this sphere, the surface, electric field, here is a tangent. Okay, that means not a enclosed by the charge. Okay, this surface zero charge enclosed, no charge enclosed by the surface. That's why they are skimming the surface. Very important. Okay. So the total electric flux here, the total flux phi, if I sum of all these, the summation E dot delta A dot product, the scalar field, and SI unit of flux is, we know the electric field SI unit is Newton per coulomb, area is meter square, so Newton meter square coulomb to the power -1, the SI unit is. Okay, so the is mathematically we solve the phi equal to integration. Okay, that means another important integration E dot delta A or dA, the mathematical expression of our flux. Okay, if we see a diagram here, a beautiful diagram. That's a 3D diagram. Consider that a 3D diagram here, and here the electric field. Suppose you that direction, that direction. That the red color represents the electric field. Okay, there is a 3D object. Okay, now we consider the three surfaces here. Okay, the surface 1, surface 2, and here is the surface 3. Actually, this electric field is goes in that direction, the piercing. Okay, and that is a inward direction, that is goes to outward. If it goes in there from the surface pierce, then piercing outward, that's piercing inward. So see that carefully and see the three, consider the area 1, 2 and 3. You see that in 1, you see the electric field in inward and the area goes outward direction. So phi of 1, that is one surface, EA cos electric field in that direction, area is outward. We know the area always that normal to the surface. If tangent, if I draw a tangent, so normal to the tangent is the area vector, that is cos. So opposite direction, that is minus 180 degree. So cos 180 is minus 1. So minus EA means a negative flux. And flux is a scalar quantity. That is important thing. Flux is a scalar quantity. Okay, because we know that that is E dot delta A, the dot product, that is means a scalar product. So that's why phi is scalar. And if I to consider the surface 2, phi 2, that is obviously here the skimming the surface, not piercing inward. That okay. So area in that direction, that is E, that is the area. So angle between these two is 90 degree. So EA cos 90 and cos 90 be the 0. So no flux piercing the surface. The skimming the surface means that this surface zero charge enclosed, zero charge bounded actually, no charge bounded by the surface. So okay, means a no charge bounded by the surface. If flux 0. Now if flux number 3, flux 3 here, we see that is E is outward and area also outward direction. That is area also outward direction. So that is EA cos, both are in same direction, means cos 0. Cos 0 1, that is EA means a positive flux. Okay. The positive flux represent that electric field is a outward direction piercing surface and negative flux indicate electric field inward direction. Okay. Okay. So write the note. So inward piercing field, inward piercing field is negative flux, and outward piercing field and outward piercing field, outer piercing field is positive flux. Is positive flux. Okay, so that is a inward piercing field, and that is a outward piercing field. So inward is negative flux, outward is a positive flux, and skimming and okay, skimming field is 0. Field is 0. So net flux. So if a net flux, that is phi 1, phi 2, phi 3. So here the net flux is minus 0. Here the positive, if that is a minus EA 0 plus EA, mathematically here 0 flux. Okay, and the loop of the integration indicate the must be integrated over the surface. Okay, if I draw a loop here, this is a loop, means a must be closed surface. This loop integral, okay, sign indicates indicates that must be over the entire closed surface. Must be integrate over the closed surface, and this is Gauss's law related to the charge enclosed by the surface. Okay, so Gauss's law Gauss's law is related to charge enclosed by the surface. To charge enclosed by the surface. Okay, so I think a basic idea of flux and what is the Gaussian law is clear. Okay, that's not complete the lecture here. Okay, so next class we discuss more about the Gauss's law and electric flux. Okay, so today end the class here. Thank you.